All right, welcome back to our conversation about different ways of expressing concentration. In our last video, we introduced kind of the more foreign unit of molality, which is again a proportion of moles of solute to kilograms of solvent. And this unit is something we are going to be using when we are talking about colligative properties. You've already seen this unit in our freezing point depression part of our colligative properties lab. So again, this unit of concentration is especially useful when we're trying to look at how the solvent is affected by the addition of solute. So this is the idea behind molality. Now going back to this idea of concentration is a proportion of solute to solution, solute to solvent in the case of molality. Let's look at mole fraction. And mole fraction is exactly what it sounds like. So define the mole fraction of a solution, which is indicated by capital Greek letter chi, so kind of like a squiggly capital X. So the mole fraction of solution is a literal fraction of moles. So let's think about what a fraction is. Remember, a fraction is a part expressed over some total or a whole. And mole, well, that's a mole, right? It's a quantity. So mole fraction is expressing our quantity of our part. So here in solutions, what would that be? Over a quantity in moles of our whole. So mole fraction is a ratio of moles of solute to total moles of solution. So this is what makes us a fraction, part over whole. Mole fraction is equal to moles solute over total moles of the solution. So this is our mole fraction. It's not a percentage, so you do not need to multiply by 100%. I know we see that often, but this will be some kind of decimal, right? Some kind of expression of a fraction. All right, mole fraction. Something that is good to remind ourselves of, just like we did when talking about solution density, is the law of conservation of matter. So this is my shorthand for that, LOCOM, law of conservation of matter. So it states that matter is neither created nor destroyed. So if I want to think about the total moles of solution, that has got to be the total moles of solvent summed with our total moles of solute. So if I wanted to, I could re-express mole fraction by saying this is moles of solute, and I'm now going to use lowercase n as a shorthand for moles. This is moles of solute over moles solution, which, applying our law of conservation of matter, is our moles of solute over the sum of our solvent and solute moles. I think it's good to kind of just keep this expanded version of molality in mind, just so that we're not forgetting one of the most important rules of physics, right? The law of conservation of matter. So why do we use mole fractions? Mole fractions are really useful in particular when talking about like mixtures of gases, or even like mixtures of, liquids themselves. Those do mix to make a solution, but when we're trying to talk about like something that's maybe not clear that something is dissolving something else, we might look at like moles of one component over moles of total component. But here I've expressed mole fraction relative to what's going on in an aqueous solution. So solute over total solution, or solute over solvent plus solute. That's our mole fraction of moles. So far, we have seen molarity, right? We've reviewed molarity. We know molarity is kind of like our daily driver when it comes to what concentration unit we use in chemistry. Then we introduced the idea of molality, which is a useful concentration term when we're trying to look at solute and solvent relationships directly to one another. And now we have mole fraction. So that's 3 concentration units. There are more. The next one, mass per volume, or mass volume percent. So M over V percent. Let's define what this is. Mass volume percent. Remind ourselves, a percent is simply a fraction that is then scaled by 100. So it's a fraction out of 100. And if we're doing mass volume percent, this means we're looking at a ratio or proportion of a mass quantity and a volume quantity. So what would that mean for us in solution? So mass volume percent is a proportion scaled to be, or make, excuse me, a percentage of solute mass to total solution volume. And the typical expression of units here is either grams per mil, which I know is a little confusing because grams per mil is what we saw for our density. This is not the same. Grams per liter, this is probably more common what you'd see when talking about a mass volume percent. Find it in gram per liter units. So then if I want to craft a mathematical expression of this, so we know that it's going to be a proportion of mass, so mass of the solute per volume of solution, and then to make it a percent, we scale it by 100. And again, this is typically in grams per liter. This is our mass percent unit. Excuse me, mass volume percent unit. And there's a reason I corrected myself. We'll talk about it in just a moment. So this unit might seem kind of similar, right? Like we've heard of a mass percent before in Gen Chem 1. So recall, a mass percent is a fraction of mass of part, or like some component you're interested in, over the total mass. So like we use this a lot when talking about compounds, right? We can look at the element that's found in a compound, its mass, and then divide that over the total compound mass. And then multiply it by 100 to make it a percent. This relationship between like mass and percentage, a mass percent, is really only useful when we're talking about solids, right? Like this is something that we talked about again when looking at compounds, not necessarily solids, but like compounds in general. Whereas now that we're in the realm of solutions, mass volume percent has a little bit more utility because, again, like total mass of solution is really not something that seems intuitive to us. It's not something that we can, I mean, I guess we could readily measure it, but when we think about measuring a quantity of solution, it's like measuring out something we can pour or a volume. So mass volume percent is especially useful in a commercial setting. So for example, if you were to go and look at your bottle of vinegar at home, you would see something like 5% acid on the label. So what does that mean? Since we are in a solution, right? Vinegar is a solution. If we're going to talk about a proportion of solute to solution, then that whole expression of the solution is going to be in a volume. So looking at our vinegar here, this means that if I had 1 liter of vinegar, found in that liter of vinegar would be 5 grams of acid times 100%. Okay. So again, if you go home and like read any bottle that has this mass volume percent unit on it, then you should be able to understand that it's talking about a ratio of how much of a solute was dissolved in grams per total solution volume. All right, we've got molarity, molality, mole fraction, mass volume percent. In our next videos, we will look at some of the more, useful and also maybe a little bit more rare concentration units. So we've talked about mass or weight percent before. Talked about it right here, right? We can do this for solutions. That's totally fine. But it's more useful to express a mass percent in terms of per volume. And then we'll look at some concentrations that are specifically useful for very dilute solutions, meaning where the quantity of solute is really, really, really small compared to the quantity of total solution. So that will be our next topic in our next video. See you then.